Welcome to Chapter 12, Section 5, Proving Triangles Congruent with Angle Side Angle and Angle Angle Side, which are shortened to ASA and AAS. This is for Integrated Math 1 or IM1. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. So let's go ahead and take a look at this. So we worked with proofs a lot last section. And a proof is quite literally not just how do I move through a problem, but why do I know I can do the things that I'm doing? I need to actually give a reason for them. So anytime that we hear terminology within a given statement, which we're going to deal with here in just a second, we get to define those things. How do we know what they mean when they say certain things? So I'm going to go ahead and take a copy of this guy because I like to have... Oops, dang it. Didn't do the whole screen. There we go. And I get to scooch this over and grab it. See, it only did a partial screen of that other one. So let's get the whole thing there. If you don't have the ability to copy and paste like that, which I know probably not a lot of us do for the current technology, especially Chromebooks, you may want to just draw it on your page. 100% suggest that you draw the diagram and you label it and you mark up all the pieces that you know. It's so much easier to follow along if it's marked. If you're just trying to remember all of the congruent pieces or everything that you've been told so far or figured out, you're going to end up missing pieces and it's a lot harder to retain and follow along. So 100% suggest you draw these diagrams as you work through the problems. So before we really look at the statements and reasons, let's just look at the diagram. What do we see? What do we notice? So first, I notice I have a large triangle with a line going down the center that actually divides it into two more triangles. So I notice I actually have three triangles here already. Just by looking at the diagram, I can see I have three triangles. I know quite a few things about triangles already. Like the angles of a triangle have to add up to 180 degrees. There are 4 different ways right now that I have to prove triangles congruent. This one should be using angle, side, angle, and angle, angle, side because, again, we have that in the title. A lot of the time the title can help us narrow things down. What am I doing today? It's not a promise that those are what you're going to use because even on the last section, it was called side, 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 and side, angle, side, and we ended up using angle, angle, side for one of our proofs. So it's not an end-all be-all for the title, but it can kind of help narrow it down a little bit. So I know quite a bit about triangles, just from what we've been doing so far in class. And then on the side here, they give me a bunch more information. So they tell me that RTS is a right angle. So RTS is a right angle. I know that. I'm given that. Am I going to have to define what right angles equal or what that means for this other side here? Yes. As soon as I hear the words right angle, I'm going to have to define something about that. Anytime we're given a word in the given like that. We're also given, tilted the page here. I want it to tilt the page. I don't know if I can get it flat. Okay, close enough. It's still tilted. I think it's now just tilted the other direction. All right, so we have this one and we're given RTU. RTU is the right angle. So we have both of these are right angles. And T is in the center, which is why I'm marking it where the T is. That's actually the, I'm going to call it the vertex, but that's the actual angle that we're looking at. The R and the S or the R and the U, these outside ones, those are the ends of the rays that create the angle. All right. So we also are given that RST is congruent to RUT out here, like this. So this is our so far given information. And I know, or I'm going to assume, that I'm using angle, angle, side, or angle, side, angle. So I'm using one of these two properties to prove these two triangles congruent. And that's my main purpose here is to prove that RST, this triangle on the, we'll call this the left, is congruent to the triangle on the right there. So now I want to say, okay, well, here's the information I'm giving. How can I get from this given information to the entire triangle is congruent to the other entire triangle? So I have angle, 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 angle. Now, have I actually been given that these two angles are congruent to each other? No. But I know that if they're both right angles, then they are congruent. And we can actually see over here, if we look at the proof, that they do in fact talk about these two angles, because all right angles are congruent to each other. I know right angle means 90 degrees. If they're both 90 degrees, then they must be equal to each other if they both equal 90. So again, I'm going to have to define that and say, okay, well, what does it tell me? What do I actually know from those words? So I have angle, angle. I can't really prove anything about these third angles, not really from the given information, but I can do something with a shared object. They both share this line, RT. As soon as my diagram or my figures have something shared, it's either going to be a segment like this or an angle, if they're overlapping triangles, then I can stop and say, that, you know, this segment must be congruent to itself. So this is a side that's congruent. So now if I'm looking at these two pieces, I have angle, angle, side, angle, angle, side. And I'd read it like this, like kind of this way, with the angle, angle, side. So I already can show that the two triangles are congruent to each other because I've identified the property that I'm using here. All right, so now that we've kind of run through this, we've tested it out on the diagram, we're going to take a look at the statements and reasons here. And this one's a fill in the blank, so all I have to do is kind of follow along and figure out, okay, well, what are they asking me to fill in here? On the next ones, we're not going to have fill in the blank, we're going to have to do all the work ourselves. So becomes a little bit more difficult there. So now I have RST, or RTS, is congruent. So RTS is congruent to RTU. And how do I know that? Well, remember, they're both right angles. We were given that information up here. And all right angles are congruent. So now I have RST is congruent to RUT. So let's see. RST. So this is was a given. I'm not noticing. They just didn't put given on there. So RST is congruent to RUT. So we didn't have to prove that as far as, going around the triangle and finding that. That was something that was given to us because we were given 3 things there. And not all the given information has to be given at the top. I tend to do it where I just put all the given information 1, 2, 3. But you can do them out of order like this. And I know on the last video I talked about the idea of a proof is kind of like getting dressed in the morning. I like this proof. A lot of the teachers, when we went through and did some of our training on this stuff, when we all were talking about how to teach it, we liked the idea of this example of getting dressed in the morning, because there's a certain number of items that you might be putting on, but certain things have to happen before others. So like if I'm talking about shoes and socks, when I get to that step of getting dressed in the morning, well, if I put my shoes on before I put my socks on, I'm going to run into some problems there, right? But say if I put my shirt on before my socks, is that going to matter? No, not really. I could have my socks on and then my shirt on, or I could put my shirt on and then my socks on. That's not going to change anything, right? So there are certain things that matter as the order goes, and there's other things that don't really depend on anything else. I can do them in any order I want, but something might depend on them afterward. Like the socks need to go on before the shoes, or the shirt needs to go on before the jacket, right? If, depending on if it's cold and we're wearing a jacket, things like that. If we could even go to like pants and shirt, it wouldn't matter which one I put on first. Now I did have, some people arguing about that because they say, well, what if you want to tuck your shirt in? So it's easier to have your shirt on and then put your pants on to tuck it in. But you could very well tuck it in even if you had your pants on first and then put your shirt on, So again, it really wouldn't make that big a difference, but for those two. But if I put my shoes on before my pants, again, that's probably going to cause me some trouble. I could probably still get my pants on depending on how tight they are, but you wouldn't want to necessarily struggle with that one. That one would cause some issues. So it's just one of those silly analogies that kind of help us, okay, there are certain steps and some depend on others. So the given information is an example of, socks. It doesn't matter when I put the socks on, as long as I do it before something else that depends on them. So like this, all right angles are congruent would be an example of the shoes. Because before I state this, well, why am I stating this if I don't know that they're right angles? So I have to state that they're right angles first, then I can define what right angles are and what that means for my diagram. So socks, shoes. This would be an example, I could have put this first if I wanted to, because it was one of my given information. It's not necessarily going to change anything what order the given information is presented in respect to each other. So I could have done this one first, because this could be like I put the shirt on and then I put the socks on. Now I'm putting my shoes on for whatever reason. Although, I'd be missing quite a few pieces of clothing there depending on what I'm wearing. But it's just that idea of some things don't necessarily matter when I state them, as long as I state them before the next dependent item. All right, so number 5 here says RT is congruent to RT. So that was our reflexive property that we talked about. So we want to make sure we choose the reflexive property there. Anytime something is equal to itself, it's going to be reflexive. So now I have angle, angle, side. So I know that the two triangles are congruent to each other. I'm going to scroll down and choose because angle, angle, side congruence. All right. So proofs can definitely be a different, process here than we're used to, because I have to be able to justify everything that I'm putting into the proof. Why do I know that that's true? How do I know? What reasons can I use? There's definitions, postulates, theorems. There's a lot of properties too. There's all kinds of different reasons that I can use, but I have to know all of these properties and reasons. So it definitely requires us to have, a bit more memory there as far as all the things that we've learned up to this point. And for some of these, we glossed over them very quickly as far as the properties and the reasons. And when you click on this too, you have this whole list here. You can click on this little I if you want a definition of it or you want to see the property. And then they're also in your notes pages. I know there's a full page of all of these. And we will be separating them out depending on when you're watching this video. It already might be done. Where they're going to be separated out so that there are also pictures of each one of these things so you can actually see a visual of them, because sometimes just reading the definition or the property doesn't really help, but seeing a visual of it is much more helpful. All right, so we're going to go to this proof here. So we have these two. There's nothing overlapping, doesn't really look like there's anything being shared, but I do see that I have two triangles here. So I have this triangle on the side, I have this other triangle on the right side. So I have these two triangles that make kind of this like pointy bow or maybe a bat shape, whatever shape you want to say is there. So I have two triangles again, and we're proving triangle congruence, so it's a pretty good bet. We're always going to have triangles there. So let's go ahead and look at the given information. We have BC is congruent to DC, so we have these two top pieces are congruent to each other. And then they also tell us that ABC, so I have to go ABC, so it's the B that I'm going to mark. And then EDC, so D's in the middle, that's what I'm going to mark. So those two angles are congruent to each other. So just from the given information, I have angle, side, angle, side. So I either need to prove this other angle out here congruent to have angle, angle, side, or I'm going to have to prove something about this angle here in the middle to have angle, side, angle. And again, not necessarily that we can't use, side, 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 or side, angle, side. But because of the title, those are the two I'm going to focus on first. If they, for whatever reason, don't work, then I'll start looking at my other properties that I can use. So what can I prove about these guys out here? Is there anything at all that I can prove about them? And really, for the given information, for the diagrams that I have, there's nothing I can prove about these two outside angles here. Or, the farthest angles, whatever you want to call them. But there is something I can prove about these two angles here. Anytime we have this X pattern happening, anytime, we can use what's called vertical angles. I can go across the vertex, and these two angles will be congruent to each other by vertical angle theorem. And we use this one all the time, so this should definitely start to be sounding familiar. So this would give us our other angle. We'd have angle, side, angle, angle, side, angle. So now I have my plan. I know what I'm going to start typing in here. And again, like I said, I just tend to send the givens to the proof, just, the first thing I do so that they're out of my way. And then I'm going to go ahead and start talking about these two angles congruent. So I have BCA. So I want to go angle BCA is congruent to angle, and I want to click angle. And because I went BCA, I want to make sure I go in corresponding order. It's going to be DCE. DCE, because we want to match up what it looks like, and I can definitely see, these two are congruent. We already know that. And then B is congruent to D. We were told that already with this given information here. I'm just looking at B and D in the centers. I already know those two are congruent to each other. And this is going to be because of vertical angle, not reflexive. Vertical angle property. So I can go ahead and validate, and yay, let me move forward. So this is definitely different. I didn't even stop and pause on this one, like I should have. That last one was fill in the blank, and we were just kind of choosing little bits and pieces. This one doesn't tell me how long it's going to be. So I don't know necessarily how many steps I'm going to have. That's why we want to kind of make a plan. How am I going to attack this problem, and go through to get from what I'm given to what I want to prove. So that was the whole reason there, to go through and kind of make that attack plan. And then I can go through and start typing these pieces in. And every time I click something, now I didn't have to do that for the send to proof because it immediately validates that. But every time I type something in here, I do have to click validate to move to the next step. So it makes you keep clicking that validate button to move forward. So it's very difficult to actually get these ones wrong as far as, get a red X on them, because I can't move forward until I've validated. So I'm not going to click check until I get to the end. If I click check right now, I am going to get it wrong because it's not done. So we'll see on this next one once I do this, because I can immediately state my prove here. The two triangles are congruent to each other because of angle, side, angle. We just proved that. So I'm going to go ahead down here and go angle, side, angle, side, angle. Clicked on the wrong one there. Angle, side, angle. And now I can click validate. Now that I see your proof is complete, now I will click check. So you can get a red X on this one, I believe, if you click check too early. You don't want to click check until you've gotten this little blue section that says your proof is complete. So the rest of the proofs are going to be like this, where we have to kind of make an attack plan. How are we going to get from what we're given to what we want to prove? And then we can kind of move forward from there. Because we don't necessarily know how many steps it's going to take to do what we want to do. Oops, click on the wrong buttons here. So again, I'm going to get my drawing over on the board there so I can start marking it up. There it is. Okay. Oops, moved over a little too far. Okay. All right. So again, I can see I have two triangles. There's one on the left, one on the right. I also have this kind of diamond or rhombus shape. I don't really know anything about that yet. We really haven't gone back into that stuff. I believe that'll be second semester when we get back into the parallelogram type stuff. So we're not really focused on that shape at all. We're just focused on, here's the left triangle, here's the right triangle. We're focused on the two triangles. So let's go ahead and look at the given information. So I'm given that ST is congruent to UT. So we have the two bottom here. And then RT bisects angle STU. I'm given this word. I'm going to have to define that word. As soon as I'm given a word, I have to define it. And if I think about what does bisect mean, that means to cut in half or having two equal pieces. So RT, this line here, bisects STU. So actually kind of going down this way, STU. So it bisects this angle, which means that they're congruent. Am I given that information? No. That's what I know bisect means. I'm going to have to put those in the proof. I'm going to have to state that. So first I'm going to have to put the given information so that I know what's happening. It's bisecting this angle. And then the next step would be to define, okay, well, if it's bisecting the angle, what is it doing to my diagram? It means that these two angles are congruent to each other. So those are the pieces there you have to make sure you're following through on. All right. So now I have side angle, like this. So if I'm trying to do angle, angle, side, or angle, side, angle, then I would want to prove something about either these two angles. And if I think about that, there's really nothing I can prove about those two angles. Either they look similar to each other, but I can't prove that they're congruent. Or I'd want to prove something about this angle up here. And again, just because it was this RT was a bisector down here does not mean it's a bisector on this side. That's not a guarantee. So I can't prove anything about that either. So if I can't prove anything about the angles, what I want to do on this one, and it kind of just means that we're not going to be using one of the ones from the title, we're actually going to take a step back to section 3 and use one of the side properties. And I know if I look at this, I have a shared side. This RT is shared. So as soon as I have a shared side, I know that the RT is congruent to RT. So this gives me a side. So now I have side angle side and side angle side. I'm just using the arrows to show you how I'm reading that. So side angle side, side angle side. So the two triangles are congruent using side angle side. So again, the title should give us a clue as to what to do, but it's not a promise that we're not going to use something else. All right, we have our plan of attack here. I know what to do. So I'm going to send a proof for my two givens. So the two pink things are sent, with the exception of I now have to define this. I know it was bisecting it. What does bisect mean? It means that it's going to cut that angle in half. So I'm going to have angle STR. So STR is going to be congruent to angle UTR. UTR. And the reason for that is I'm defining the word bisect, and not only bisect, but angle bisector. So I need definition of, where is it? Angle, congruent angles, angle bisector. There we go. Definition of angle bisector. And yes, this list is a little longer, so it may take you a minute to go through and decide, which one exactly am I using there. So it definitely gets to be a very long list very fast. All right, so yay, we validated that guy. So immediately I can move into this send a proof. I know it's side angle side. All I needed to do was put the givens in there, state that one side congruent to, oh, nope, I'm actually fibbing. I can't do this yet. That was just defining this down here. I still have to state that this RT is congruent to RT. I almost forgot about that because I wasn't even thinking. Let's see, congruent. Uh-oh. This would get us a wrong answer. We don't want this line over the entire thing. Make sure you click the over arrow, or like use the mouse to kind of click out and then click it again so that you don't have that segment line over the whole thing, because that will mark you wrong. It won't let you validate that because it's not correct. So this is the reflex property. I almost forgot about that guy. We needed to throw this one in there. So now I have side angle side. Now I can use my proof, or my prove, send a prove. And the reason is I'm using side angle side congruence. All right, so we're gonna check, we're gonna keep moving. So this section, it's 4. Let's go ahead and grab this guy. Okay, so we're given a couple of pieces about these two triangles again, and if I'm looking, oops, I didn't want to look at layers. If we're looking at the two triangles, so we have ABC, and this, and we want to prove that ABC is congruent to DEC. So these are the two triangles we're looking at here. And that might help too, just highlighting them different colors, something along those lines, just so that you can kind of see the two triangles a little nicer there. And we're given that C is the midpoint of AD. All right, well, I'm given some information, but I'm going to have to define what does that mean? What is the midpoint of something? So if I know that C here is the midpoint of AD, and I know the midpoint means it's in the middle, well, that means that the two sides are going to be equal to each other. C is the midpoint. AC must be equal to CD because it's in the middle, right? Again, I'm going to have to define that. I haven't actually been given this information that they're congruent to each other. I'm deciding that because I know what midpoint means. So I'm going to have to put that in the proof. The other piece here that I'm given is that AB is parallel to DE. Okay, well, what does that do to my diagram? What can I prove using that? So there's a couple ways to attack this problem. I can definitely focus in on the parallel lines, and I would be using alternate interior angles. And I'll do this in pink, I guess, because I have parallel to transversal. And then if I go alternate side and slide all the way down to the other parallel, I have parallel to transversal. These are called alternate interior angles. So I know that A is congruent to D, and I know that because these are parallel. I have to state this first before I can start saying that angle A is congruent to angle D. So again, shoes and socks, okay? Paying attention to what I'm putting in there first. Will it matter if I define the midpoint, put this piece in the midpoint before I start talking about parallel lines? No. I could talk about parallel lines first, and then I could start talking about the midpoint. Okay? Those don't necessarily matter. But if I want to say that AC is congruent to CD, I have to put the midpoint piece in here, the given thing, before I can state that. Otherwise, how do I know that AC is congruent to CD? Based on the fact that, what a midpoint means, a midpoint definition. If I wasn't given the fact that it was a midpoint in the first place. So, hopefully that idea of, there's definitely more than one way to put these into the proof makes sense. There are certain things that need to go first, but I can do other pieces out of order and it's not going to change the outcome. So, using the parallel lines, I can do these alternate interior angles. I can also do the exact same thing to the other side because this can also be a transversal. And I could go, B is congruent to E. Again, using alternate interior angles. I can also, so this is where we start getting a whole lot of options, use vertical angles and say that these two kind of inside angles are congruent to each other. So I'll do 3 marks here, like this. So I can show that all the angles are congruent to each other at this point. Remember, we don't have angle, angle, angle. But because of this, I could use angle, side, angle. I could use angle, angle, side. I could use angle, angle, side going this way. So more than one way to prove that these two triangles are congruent. These two pieces of given information give me a whole lot, honestly. So I can prove quite a bit from these two given pieces of information. So let's go ahead and send this to proof. And I'm going to do this in pieces. Because I'm doing the midpoint, I'm going to go ahead and say, what does that mean? So the midpoint means, if that's the midpoint, that means that AC, and I need to make sure that I put my segment line over the top or it'll mark me wrong, is congruent to DC. So AC is congruent to DC. And if you put this backwards, if you put AC is congruent to CD, I don't think it would mark you wrong. The segments aren't as picky about the corresponding order. I just am really picky about it. I think it's a good practice to just always put them in corresponding order. So this is definition of a midpoint. We're just defining what does midpoint mean. All right, so now we're going to do the second given. I'm going to send that to proof. Would it have mattered if I just put send to proof, and I had given? No, it would not have changed anything. Again, just some of those pieces can be out of order a little bit, and it still gets us to the same end result. All right, so I know that they're parallel, so I can use those parallel lines to show that alternate interior angles are congruent. So I can say angle A is congruent to angle D by alternate interior angles. So I need to scroll down and I'm going to have to actually do if lines are parallel, then alternate interior angles are congruent. So you have to look for that whole statement there. So now I could do the same thing with B and E, or I could look at angle C on these two. Now I can't just put angle C on these ones. I can say A and D and E and B because those are the only options. Angle C could be any one of these 4 angles here, because these outside ones could also be called angle C. So I'd have to be very specific and say A, C, B, and D, C, E, something like that. I'm just going to go ahead and go with angle B. I'm going to do alternate interior angles again. Why not? Angle B is congruent to angle E. Again, if 2 lines are parallel, alternate interior angles are congruent. So because I used the 2 pink ones and I had the blue, I'm going to have angle, angle, side. So I can go ahead and send this to proof using angle, angle, side. Angle, angle, side. If I had used the vertical angles, then it would be angle, side, angle. So you just got to be careful which one are you using, what's the order there. All right, my proof is complete. We have 2 more of these guys. I believe we're going to start using what's called CPCTC. Sounds like a whole lot. It sounds very fancy. It's the step after proving the triangles are congruent. So let me go ahead and copy this and I'll tell you what I'm talking about. Oh, dang it. There we go. All right. Okay. So let's go ahead and view this guy and see what they're asking us to do. So I can see again, I have my 2 triangles. So I'm going to go ahead and mark these guys up here. Help if I had straight lines. There we go. Well, that's still not going to be perfect, but oh well. I'm going to go with it. I'm just going to leave it alone. And then we'll go with red for the other guy here. So we have our 2 triangles. And it's not actually asking me to prove triangles congruent. But we are still going to prove triangles congruent. And then we're going to use those congruent triangles to show that congruent parts of congruent triangles are congruent. And that's actually what we call that CPCTC. Congruent parts of congruent triangles are congruent. And I'm going to write that out in a minute here so we can actually see the letters. Because instead of saying all of that, you know, congruent parts of congruent triangles are congruent, we just say CPCTC. We just bring it down to the basic letters there. So we're kind of moving a little past just proving triangles are congruent here. So let's go ahead and mark up our diagram. So we have DE is congruent to FG, and then we have angle EDF is congruent to angle GFD. So this is another one. If I wanted to prove parallel lines, I actually could on this one, because just like we used the parallel lines mean that alternate interior angles are congruent. If I have alternate interior angles are congruent, I can prove parallel lines. So we will actually get to a point where we do that, where we want to prove lines are parallel using this kind of an idea. We don't really care about it right this minute, so I'm just going off on a little tangent there. But we have our given information. I don't need to do anything more with that given information as far as proving or defining. I'm just going to start using the next pieces. So these 2 definitely have a shared side here. And I'll go with yellow, I guess. So they definitely share this side. I can see that. That's, you know, the what do I see? What do I notice? We want to make sure, you know, take a look at the diagram. What do I notice is happening about this diagram? If you don't take a second to notice, then it's going to be a little harder to move forward. So slow down. What do you notice about your diagram? How does that help? How do I move forward? So these are going to be congruent to each other. FD is going to be congruent to FD. So I already have side, angle, side for these guys. Side. Oh, what happened to my other mark there? I didn't notice it disappeared. I thought I put it down there. Side, angle, side. So I can already show these 2 triangles are congruent to each other. Well, why does that matter? when I want to know if the angles are congruent to each other down here. So I actually want to show that keeps disappearing. EFD, and I'm going to put this in red, I guess. EFD, this is what I'm proving, is congruent to GDF, so this one up here. Well, if the two triangles are congruent, then the corresponding parts of congruent triangles are congruent. So this literally means congruent parts of congruent triangles are congruent. And I know I only put the word on part because I don't have a symbol to go with that. But this is not a G, this is a C. Sorry, that's a very ugly C. But so we literally just say CPCTC. Once I know one triangle is congruent to the other, the corresponding parts have to be congruent to each other. So F and D would be the corresponding angles to each other. And I can even see that in the proof here. F and D are both in the middle of this piece. And even up here, I have F and D on the end, or on this one it's D and F in the middle. I know they're kind of switched around there, but it depends on how they're corresponding to each other. But they're always in the same position when we talk about them, which means they're corresponding to each other when we say that the triangles are equal or congruent. So we have our plan of attack. We're going to go ahead and start filling this guy in. So I'm just going to send both of these guys to proof. And then I need to talk about this shared side. So segment DF. Oh, why didn't I do it? Segment DF is congruent to segment DF. And that's by reflex. Anytime it's shared, it's a reflexive property. So now I can actually send, I could send this down to proof if I wanted to, using these ones, because I'm being a little lazy and I don't feel like retyping this. And I could just go back and go undo and triangle. And, oops. Why did it highlight the whole thing? Undo and triangle. So I was being a little lazy there, so I don't have to type in so much. Because right now I need to prove the triangles are congruent, then I can prove their corresponding parts are congruent. So I can show this because it's side angle side. So I'm going to go down and choose side angle side. Whoa, what happened? Kind of moved up there. Side angle side congruence. I'm not done yet. Now I can send this to proof for real. So I'm not going to change this one. I'm going to go down and choose CPCTC. And they do break this down for you if you want to see the words for it. Corresponding parts of congruent triangles are congruent. And I can validate, and my proof is all done. Yay! So, one more of these guys, and I believe we're going to use that same idea of CPCTC. We're going to use it twice here. Because anytime that we have two triangles, and we want to prove parts are congruent, first we're going to prove the triangle's congruent, then we're going to use CPCTC for the corresponding pieces. So it's just the second part of that. Why we would want to show triangles are congruent is so that we can use this next piece of the corresponding parts are being congruent. So we practiced that a whole lot of proving triangles congruent, pretty much so that we could keep going and moving forward into this next piece of using this idea of the CPCTC. All right. So I have two triangles, and I'll go through and highlight these guys. So I have two triangles. And this, whoops. There we go. All right, let's turn the line tool off. And now I'm given some loaded information. EH bisects DG. I'm going to have to define that word bisect. What does it actually mean? So if EH bisects DG, then this line, and I know I didn't do that very nicely, but this line cuts this other one in half. And that means I have two equal pieces. I'm not given that outright. I'm given the word bisect, and I have to define What does it mean when a segment bisects another segment? So I'm going to have to define segment bisector. The second part I'm given is that DE is parallel to GH. So again, I'm going to have to use that. What does that mean? So I can go through, and we did this one just like we did on, what was that, number 4 or 5? That was just a couple sections, or just a couple problems ago, when we were using alternate interior angles. So I'll do that in yellow. So I can go D would be congruent to G because these are alternate interior angles. I have parallel to transversal, parallel to the same transversal. Or I can go E, so this is parallel to the other transversal. And then the bottom parallel to, again, the other transversal. I can also use vertical angles here, because anytime I have that X where they cross, I can use vertical angles. So again, ton of options to say that the red triangle is congruent to the blue triangle, or the red triangle is congruent to the black triangle there. And I'm just using colors instead of the letters. Once I've proven that the triangles are congruent, then the corresponding parts will be congruent. So I definitely have my plan of attack here. I just have to decide on which path I'm taking. There's 2 different ways. I could use this vertical angle and 1 alternate interior angle, or I could use 2 alternate interior angles. So if I use the 2 alternates, it's going to be angle, angle, side. If I use the vertical angle, it's going to be angle, side, angle. So it just depends on which path I take there. But either one is correct. It's really not going to change much. So let's go ahead and send this guy to proof. And I'm doing this in pieces, so now I can define, okay, well, what does this do to my diagram? This means that segment DF is congruent to segment GF. And that is because I'm defining that segment bisector. So definition of segment bisector. All right. This next one, I want to send to proof the parallel lines. I could, if I'm going with the vertical angles, I can say this at any point in time. This does not depend on any other piece of information, this vertical angles. So I could have said that as number 1 if I wanted to. But I just haven't decided if I'm using that yet or not. Let's see. So I'm going to go, I know they're parallel, so now angle D is going to be congruent to angle G. If 2 lines are parallel, we have to make sure we're choosing the right one. Alternate interior angles are congruent. Perfect. I'm going to go ahead and use the vertical angles here just to show you, because I know last time I did the 2 alternates. So make sure you can't put angle F, because the F could be either one of the blue ones, or it could even be these outside ones that we don't want. So I'm going to go DFE. So angle DFE is congruent to angle, and I don't want to come down here to H because D corresponds to G. So make sure you go GFH. GFH. And the reason for that is they are vertical angles. So let's go down and find vertical angles. There it was. And validate. Okay. So now I've used vertical angles. I have this side congruent. We've stated that already. And we've also stated that this angle is congruent to this one. We did not do these ones over here. These other yellows with the 2. So I have angle, side, angle. So I need to go triangle. And I can actually use this exact same order I just did here. DFE is congruent. And that's actually as long as you make sure that they're in corresponding order, which I did when I wrote this out. So, you know, it should make you put these in corresponding order, I think. But it's not actually a requirement sometimes for the angles, because it's just the name. So that's not necessarily important for the angles to be congruent to each other, but it's an important step in just making sure we practice that corresponding order. So this is by angle, side, angle. I'm going to scroll down and find angle, side, angle. And validate. All right, so now I have the 2 triangles congruent to each other. So all of their corresponding parts must be congruent. So that means that EF is going to be congruent to HF. And if I look here, I have EF, which would mean I'm kind of going backwards, HF, I'm kind of going backwards, right? So those are in corresponding order. So I can go ahead and send this to proof, and I'm going to use that bottom one, which is CPCTC. Congruent parts of congruent triangles are congruent. All right. Sorry, corresponding parts of congruent triangles are congruent. I keep saying congruent at the first one. It's corresponding parts. I apologize for that. I keep mixing up my C's there.